Okay, why don't we go ahead and get started? It is my pleasure to introduce Kaylin Bugbee, who is the lead for the Information Management Focus Area within the Office of Data Science and Informatics at NASA's Marshall Space Flight Center. So today she's going to talk to us about data governance for enabling open interdisciplinary science. So without further ado, I'll hand it over to Kaylin. Kaylin, thank you for being here.
Thank you so much. Thanks for the invitation, and I'm excited to be here uh, and to share what we're working on and get some valuable feedback. Again, thank you for having me. I'm Kaylin Bugbee, and I'm at Marshall Space Flight Center. So I wanted to talk to you about data governance, and then data governance is a team sport, and how we're building governance that enables science. You see a list here of my team who have been working hard to make all of this happen, but also we have an amazing community of people in the data stewardship community in NASA Science who have been wonderful in supporting us on this journey. So really just want to acknowledge and appreciate all of the people who work to make this happen. Okay, so through this presentation, really want to explore this topic of if we really want to move from isolated data sets to a world that's enabled by accelerated discovery and the potential of AI, then we really need this cross-domain collaborative governance of data and information. So as we go through the slides, I'll provide a little bit of context of what we do in NASA Science, take you on a brief journey of the history of scientific data management at NASA and why we are looking at governance at this moment and this time, and what our vision is for governance in NASA Science. I'll talk about our current process and current efforts that we have, along with our work to build that community that I mentioned. And we'll close with some lessons learned and the future of where we think we're headed. So some just to have some context, at NASA we study space science, which essentially means that we are um, building new knowledge that's contributed by the means of space vehicles. So in this context, that can mean satellites, sounding rockets, airplanes, the space station, and we cover a wide range of scientific topics. So we cover astrophysics, biological and physical sciences, earth science, heliophysics, and planetary science. And on the screen here, you can see it kind of give you an idea of the diversity of the kinds of things that we do in NASA. Everyone loves our rovers on Mars. We do experiments on the space station looking at plant growth and other things. We have airplanes that take measurements of ice in the South Pole. Um, we have the telescopes that we all know and love, the James Webb Space Telescope and the Hubble Space Telescope. We have a number of Earth observation missions and satellites that are taking pictures of the sun. So this should give you a sense of the diversity and heterogeneity of the kind of scientific data that we have at the science level at NASA. Um, so as you might imagine, that's pretty complex landscape to navigate. So there's about 130 plus missions across those 5 topical areas with over 140 petabytes of data. Those data are cared for across a number of repositories. You can kind of get a sense of that from the graphic on the right. And we have 10 million plus users who are excited to work with the open data that we provide. And each of those domains or topical areas, they do have their own standards, community standards that they follow, and community accepted ways of working. So that's the context. And I did want to give some background on our origin story as how we've managed scientific data at NASA and how that how we've perceived that work and how it's evolved along with technology changes. Um, and also, I find that looking back informs us as we look forward, and this both in establishing governance, but also in the future as we get ready to think about AI. So the first space science missions at NASA were essentially demonstrating what is possible, what can we learn about the universe from the vantage point of space. So we had a number of experimental satellites that we launched. Explorer 1 was looking at solar particles, and we discovered the Van Allen belts. One of the early meteorological satellites was called Tiros, and it took pictures of clouds and really demonstrated the importance of the advantages that having a satellite in space could provide for weather observations and predictions. But a lot of that early data was very physical. It's not digital like what we're used to now. So in this picture, you can see these are film canisters of mostly Apollo images. This is the Lunar and Planetary Institute Library in Houston. But this would be the kind of data management that we would do in the early days. And so you see on the left in this image a data printout from Mariner 2. Mariner 2 was the first mission to fly by another planet, it flew by Venus. It didn't take images, but it did take data. And you can see the printout there. They've scrolled out here on the left. And that was fairly common to look at data at that time. The image on the right is from Mariner 4. This was the first mission to Mars that took a camera. They took pictures, but data processing took so long at that time. They had the data, but to convert that into an image, the scientists were so excited. They didn't want to wait for that process, so they actually took the data and did color by number, if you will, of the first picture from Mars. So that's what you're seeing on the right, and it really just shows like how long things took in the early days to look at data. Browse imagery at this time was very literally physical. So we had facilities around the country where you could go and actually pull a physical image. This is again at the Lunar and Planetary Institute Library. The image on the left is an Apollo image, and then the corresponding metadata is the card on the right. And this is Apollo, but there were similar things available for Voyager images and other science data around the country. And data systems themselves were a new thing. So this is a picture of an IBM 7094 that was the first computer used for data management, data system processing. The 7094 was originally used for Apollo, like trajectory calculations and things like that. But then we started looking at whether we could use them for data systems. This is images from the mid to late 60s. And when we were doing this work, this computer was already obsolete, but we were trying to figure out what was possible. And given the physical nature of the data and this data could be very fragile. So this is an image of a incident that happened in one of the tape rooms. So the physical nature of data meant that accidents happen, and there's the work that goes into maintaining the data and making sure that it's still viable and usable as formats change and decay. So we're in the time in the 60s and 70s of very like physical data and data management, and very much you could say constrained by the physical nature of data. But as we entered into the 80s, it really represented a moment both on the technology side, on the science side, and on the data management side. So on the science side, we began to really harvest the data from all of these remote sensing missions, and really began to understand that we could use this vantage point of space to answer these bigger, deeper, complex science questions. So we started to think that we could answer questions about Earth as a system, we could look deeper and further into the universe than we ever had before. And so some of these questions, like this is an image of the discovery of the ozone hole, was really made possible by the maturity of our observing capabilities at this time. And it was around this time that networks emerged, and we started to think about how data and interacting with data could be more digital. So there were groups experimenting with the network capabilities. I know that NSF has a really strong and rich history around that too. We were trying that here at Marshall with the Space Physics Analysis Network and really started to demonstrate how data access and analysis could be more digital and how we could collaborate with others around the country in a more seamless way. And on the data management side, in the 80s, a number of National Academies reports came out saying, really encouraging the development of a systematic data stewardship and data management community to just support the ever-growing data volumes of the space science data that we had. So it was in this time that we conceptualized some of our major systems that exist today. So you can see the planetary data system on the left and the Earth observing system, data and information system on the right. And these really established the data management communities and support that was needed to really make the science data available and usable. So that nexus of big science questions, technology, and a greater emphasis on data stewardship and management really enabled us on the science side to really answer some of these big questions. So you can see one of the deep field images here from Hubble. It really could answer some of these big questions about the universe and also about the Earth. We were able to gather data and put together data that told us a lot more about Earth as a system and how those things interact together. So today we're entering very much a big data era. This is an image of Mount St. Helens from NISAR, which is one of our major Earth observation satellites that we collaborate with the Indian Space Agency on. NISAR represents 80 terabytes of science data a day. So just the sheer volume of data that is coming in across the science portfolio is just increasing. And we are also seeing an increased value for scientific data management, especially as we move into this AI era. So if you look back at on this journey where we've come from, very much everyone just take each PI taking care of the data to a more systematic support system there and data stewardship and management. We've come a long way on our journey. So we've developed policies to enable open sharing and open data over that time period. We've worked with the topical communities to develop standards that make it easier for our communities to work with the data. We've gotten a lot better at user services, and of course that was really enhanced with the advent of the internet. Before that, it was a level of effort. If you could wrangle up the time to make those physical copies of that data and get it out. We've really built our collaboration and partnerships, collaborating with other agencies in the federal government and around the world, and that makes finding data easier. And we moved away from a kind of ad hoc way of taking care of data to this network of active archives and repositories that really helped us with our data stewardship and archiving. And I think the biggest thing is that we've seen an increase in our user base and the number of people who want to access and use our science data. Originally it was thought that only the principal investigator would be able to and want to work with the data, but as the open data paradigm has expanded and science has grown, we have a number of people coming to use the data, including educators, policymakers, commercial entities, and the public. So, highlighting this broader benefit of open access to data. Um, and of course, digital resources like the internet have made participating easier. It hasn't, I wouldn't say I have eliminating barriers. I wouldn't say it's eliminated, but it's definitely made it easier. And so this really demonstrates the success of all the work that's been done to really establish a stewardship community and the policies and efforts that went in place to make that happen. But we still have opportunities. So we have those community standards, but compliance or adoption of those is variable. Um, we do have some legacy data that remains with the PIs, and we also have that some of that older data that you saw earlier that needs to be rescued, and resources are limited for that. Um, Especially with the advent of AI, we've always known data was important, but all this other contextual information, including software, become just increases in importance for that context, but it's often buried in a number of different places and not necessarily standardized. So that can be a challenge. Um, and then as we continue to move into more AI and more data science, we need that literacy and training for our community to help us evolve and adapt into the new era. So, given that brief, quick history, like why now? Why governance now? So we've really been focused on our individual missions, our topical areas, and our data systems for those topical systems. But now I think we acknowledge that that cross-disciplinary science is growing. We have this expanding data ecosystem and this growth of AI that really requires that we have governments that operates not just within each of those topical areas, but across as well. So, given that emergence of AI, this commercial data paradigm, and integrated science, we feel this is the right moment for science-wide data and information governance. So now I'd like to just briefly touch on how we define data governance. So we define data governance as guiding each step of that data and information management lifecycle. And it does that by establishing best practices and guidelines for managing that data and information. And those best practices should enhance our current data practices to accelerate and streamline science. And in this context, we're using a broader definition of data or data and information. Of course, that includes the science data that's stored digitally, but it also includes the science and technical documents and other information produced by the missions, including calibrations, coefficients, and algorithms, computational simulations, and digital data about physical samples. I will say I kind of think this definition of data is probably going to change and grow as we figure out what we need to steward and preserve on the AI side. But I would not be surprised if we see this change and evolve a bit. So, why do we need governance? Well, we want to maximize the value of that data. As I mentioned, we have a large user base, and so anything we can do to make to ensure that data is visible, accessible, and usable is great. We do want to enable efficiencies for both our data providers and our data stewards by providing clear guidance on requirements. The next big one is that making data AI ready. So we can enable those rapid science returns and evolve and adapt for this AI ready world. We really want to foster collaboration and knowledge sharing across our data steward community. I'll touch on this in a little more depth later, but we've really acknowledged that we have so much that we can learn from each other, and we've been siloed in the past. And so bringing each other together and learning from each other has become very valuable. We do want to make it easier for our scientists and missions to meet requirements on around open science and open data. And of course, we have federal and agency requirements that we need to meet. But we do have challenges, as I'm sure you can imagine. I did touch on the diverse and complex nature of our scientific data and information. So that makes governance of those a challenge. Um, Historically, we've been siloed in our standards. And that's great because it's helped enable the communities to work well. But greater coordination and collaboration is needed across. And we'd also like to make it easier for people to find best practices because they can be dispersed. We'd like to place more of an emphasis on software and documentation. We've always tried to take care of our data, but software and documentation was sometimes not viewed as in scope, although it's very important for the context around the data itself. And there's not a lot of best practices in our community to support those, so we want to work to foster that where we can. Um, the rapid evolving technology and AI, it does make it difficult, and it introduces uncertainties into how things will affect governance. Um, and on the data provider side, the easy to understand guidelines or best practices are not always available or easy to find for new policies. So as we go on this governance journey, we have a number of principles that we've been following. So we want to focus on practical governance activities that enable science or value and leverage streamlined governance to achieve outcomes. We want to be collaborative and embrace that collaborative approach. And we want to try to minimize that friction around governance by providing tools, easy to digest recommendations, and training where appropriate. And we haven't gotten there yet, but eventually we do want to move to more measurable governance outcomes where possible. And the outcomes we want to achieve are enabling that interdisciplinary and open science, increasing that interoperability across data and systems. We want to reduce that friction for our scientists and our data stewards by making it easier to be compliant. And then, of course, we want to ensure that we meet our compliance with government and agency policies. Okay, so now that I've talked about why governance and why now, I was going to pivot to talking about the process that we've adopted. We're about 9 months into this, so we're still very much what I would say in the early days of trying this process. And so I look forward to sharing that with you and getting your thoughts on it. So this is our governance structure. So we do have an executive level sponsor that provides the oversight and direction for the work and helps champion what we're doing. So in NASA Science, that's the Office of the Chief Science Data Officer. We also have a governance board that helps us both validate our strategy and our initiatives and helps us determine priorities. So we have a board that helps us do that. We have the data governance manager who identifies what needs exist and develops solutions and making sure those align with agency policies. And so I think I mostly function as that, but I have an amazing team of people that I mentioned earlier that help make all that happen. And then we, as the governance team, we collaborate with our data stewards who both help provide input to the governance work that we're doing, but will also be utilizing the guidance to implement the best practices. So we're very fortunate to be able to collaborate with our science data officers who provide the vision and leadership for each topic, and they also work with their data stewards in their divisions to make sure that we're collaborating on this governance effort together. And so this is the high level process of how we've been working on governance together. So first we identify a governance need, and that can be driven by a number of things, including policy. So we have a number of policies that our stewards and our data providers are um, trying to understand how to comply with those. So it could be that we develop initiatives around providing clarity on answering the policy. Other drivers include enabling efficiencies across our organizations, or things that support common ways of working and sharing. And a couple of the initiatives I'll go through are really foundational in that common ways of working space. So we identify the needs, then we need to select which ones we want to work on. And the selection criteria for that really aligns around leadership priorities, what's most important from the executive leader's perspective, what the community is telling us that they really need support on, um, and also if it's something that we can respond to help with rapidly emerging problems. So once a need is selected, the team works to draft an initial guideline. So to do that, we do some preliminary research. We take a look at similar efforts that are happening with our data stewards within those topical areas, but we also look at other activities that are happening across our scientific data stewardship community. So we do that preliminary research. We also survey or interview our stakeholders as we can, and we synthesize all that into a draft guidance document. Once the draft is complete, we send it out for community review. So we have a biweekly meeting with our community. They send us feedback, and we adjudicate that and update our guidelines as needed. Once the community's review is complete, we send it out for leadership review, also adjudicate the feedback there and receive sign off, at which point the guidance would be released. And we also, where appropriate, we release the guidance and any kind of training or other support that would go with it. And we haven't actually released anything yet. We're pretty close, but the commitment is to periodically review and update guidelines as needed. So we have four initiatives that are at various stages in that process that I just wanted to touch on. So they are a governance lexicon where we're looking to develop common governance terms across our communities. The data management lifecycle, which is similar, where we're baselining the lifecycle phases with definitions, purpose statements, and lifecycle aligned roles. And then minimum metadata, so identifying a core set of metadata that will help improve discovery, and decision tree, which is meant to help aid with a data provider in determining where their data should be shared. So I'll just go into a little bit more detail. Um, we have an annual meeting where we all get together and share what we're working on. And in one of those meetings, we realized that we have different words for the same thing, or a word has a different meaning within different communities. So one of the first things that we really wanted to work on was developing this collection of terms and definitions and synonyms related to our NASA science data governance and data stewardship. And it's really just meant to build community, make it easier for us to communicate across and to understand those different synonyms. So we're really hoping to establish this unified term set to strengthen our communication both within and across our topical areas or divisions. And similarly, um, on the data management lifecycle, we also want to define a science-wide data management lifecycle model. so that we can also have normalized terms and definitions there as well, to help facilitate that communication and understanding. And that will be for each stage of the life cycle and those associated roles. So having clarity of the stages and the roles is really important for the community. Um, on minimum metadata, we've been working to provide a set of minimum metadata requirements. This is to help enable discoverability and usability, while still acknowledging that our domains have their own metadata that they need for domain-specific search and discovery. So as we move toward this more open science, interdisciplinary world, it's important to have this common set of minimum metadata so that we can enable that scientists to discover resources across in this interdisciplinary science use case. We do have federal and agency requirements for metadata that we want to make sure that we meet. It's also important for the long-term preservation and reuse of this information. And we also want to provide a consistent experience for our users utilizing the information that we have. And then last is decision trees. So it's meant for our data producers who have data that they want to share, and is meant to be as a guide to help them navigate where to begin when they have data they would like to submit. So it's hope that it will clarify those first steps and help a data provider provide the right place to go for sharing data. So all of those four initiatives that we just walked through, they're all in varying stages of the process. Lexicon, we're getting very close to releasing the first batch of terms, and the others are in various stages of review. So speaking of review, I wanted to touch on our governance community. They're an amazing group of people to work with. And so we have this community of practice that we really want to foster that interdisciplinary collaboration across the topical areas. And we want to come together and address challenges in data and information management, and really work to promote stewardship as a discipline in a community. We want to provide that common language for governance. So you saw that through the lexicon initiative and the data management lifecycle baseline activity, and sharing those best practices and challenges between and within our divisions. So we find that there's everyone has something they're doing really well that they can bring to the table, and it's really great to have a place to be able to share those best practices and lessons learned. We do have an annual meeting, and that's the primary event where we come together and share and learn from one another. So in these meetings, we work on our strategic vision and our priorities. It's a good place to identify some of those governance needs that I mentioned a bit earlier. We provide opportunities for the community to share. So we've done e-lightning presentations in a more virtual way, and then we've had poster sessions. You can see pictures of that on the slide. And we try whenever we can to have these community-led breakout sessions, and we've explored a number of topics, including the data management lifecycle, what does it mean to be fair, metadata quality, and preservation. So our this year's meeting is coming soon, and it's going to be really important because we're going to really try to understand how, as data stewards, how can we align for the AI era, and how can we unlock our data for discovery and analysis in this environment. So we'll really be focusing on AI. And also on the NASA side, we have this emerging commercial data paradigm. And we really want to explore how these things are reshaping our role, responsibilities, and practices in data stewardship. And that will really probably drive some of the governance initiatives of the future. The ones that you've seen so to date are very foundational. And I think this will give us the discussions and information we need to start thinking about governance that's needed in this space in the future. Um, so that's the annual meeting. We also have a more frequent touch in that we're calling our community coffee chats. So those happen on a biweekly basis, and we mean those to create a space for more open discussion and learning at a more frequent pace than just the annual meeting. We've had discussions about the annual meeting is infrequent enough, so the community coffee chat is meant to provide a place to have more discussions at a more frequent time scale. And again, continuing that model of sharing our challenges and progress and lessons learned and bringing together our data stewards so that we can build a shared knowledge base. And so, as I said, it's twice a month. And so we try to spend one of those focusing on those initiatives that I described and the status of those and getting input from the community on those. But we like for the second session to um, be a place for our stewards to share what they're working on and provide any updates or lessons learned there. And last on the building the community, we're really excited because we've been working to build a governance knowledge hub. Um, we call it the Governance for Understanding, Accessibility, and Collaboration, or GWAC, Community Knowledge Hub. And this is meant to be a digital place where our stewards can come and ask questions through a forum. They can learn more about upcoming events and participate in initiative reviews and just really build a community there as well. We've released the beta just recently, and we're looking forward to a full release later in the year. So just to close out, I wanted to touch on a few lessons learned to date. As I mentioned, it's still a little bit early in our process as we're learning how to do this, and then just touch on looking ahead and where we're going. So some of the lessons we've learned to date, one of the exciting ones is that it's been amazing to really work with our community and our data stewards. So they've been consistently willing to help us to provide feedback and their expertise. So it's been a wonderful experience, and it's really enabled productive discussion and iterative refinement of these concepts. So it's been really great to collaborate and work together on these things. Um, on the needs side, identification of needs is a little bit slower than we expected. I think collectively we're all trying to figure out what needs look like and what's appropriate at the enterprise level versus the domain level, and trying to find that sweet spot for the scope of those needs. So that I think we're still trying to learn how to identify and prioritize needs. I would anticipate that as we understand this AI question a bit more, that need identification will accelerate. Um, Awareness of what we're doing has spread informally, so there's a little bit of a lag in community engagement, but um, it's really we've really started to see more people come in as word of mouth has been spread, and so our coffee chat has grown consistently in attendance, and we have a nice representative group of our data stewards in the coffee chats regularly now. And then the last is we assumed that we would all be on the same page, but that doesn't always happen. So we've been trying to be explicit up front as to the goals of what we're doing, and that seemed to have helped. So I just wanted to close with thinking about the future and where we're headed. So my friend Tom Morgan, he said that there are always things to be wrung out of data. You only look for what you ask a question about, and if you didn't have the question in your mind, you didn't look for it in the data. And I think as we see this emergence of AI along with these new data streams, there's going to be a lot more things that we can wring out of data, a lot of new things. So, in order to make that happen, it's really important that we continue on this cross discipline, cross domain collaborative governance that will make our science data and information reusable, trustworthy, and AI ready. And so I think that once we get our governance things established, we'll really start to lean into this governance around enabling um, cross domain science and AI. So I just want to conclude by saying thank you. I look forward to questions and discussion. And if you have any questions about this, please feel free to reach out to me. We're also always looking uh, to collaborate on these kind of things. So happy to talk. Thank you.
All right. Well, please all help me thank our wonderful speaker, Kaylin Bugbee, and we'll see you at the next one. Thank you very much.
Thank you so much. This was great.